Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem. Alright, so in this video, I'm going to be solving the equation 6 to the power of x is equal to 60. So to solve this, what I'm first going to do is I'm going to be taking the log on both sides. So I get log of 6 to the power of x is equal to log 60. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front. This can equal b times log a. In this case, I have log 6 to the power of x, and I can move x to the front. So I get x times log 6 is equal to log 60. Now from here, I'm going to divide both sides by log 6. So then these two cancel out, and I get x is equal to log 60 over log 6. So now from here, what I'm going to do is I'm going to rewrite log 60 as log of 6 times 10. And if I have something in the form log of a times b, this is equal to log a plus log b. So log 6 times 10 is going to equal log 6 plus log 10. And I evolve this over log 6. Now, from here, if I have something in the form a plus b over c, this is equal to a over c plus b over c. So log 6 plus log 10 over log 6, I can write this as log 6 over log 6 plus log 10 over log 6. Now, log 6 and log 6 cancel out, so I get x is equal to 1 plus log 10 is also equal to 1. So I have this over log 6. And if you guys already didn't know, log 6 is equal to log 3 times 2, which is equal to log 3 plus log 2, which is equal to 0.7781. So if I plug this in for log 6, I am left with x equals 2.2852.